root theorem. This will give us all the possibilities to try to find a perfect zero when we are factoring maybe something with a higher degree that we might not be used to. So here's the basic idea of it. It's going to say all the possible factors can be listed as all the factors of p, which is the last number on there. It's the number with no x's. It's the constant. So we're going to list the factors of 27, all of them, over the factors of the leading coefficient. Now the leading coefficient is basically the first number, which in our case would be 1. So we're going to put all the factors of 27 over all the factors of 1. So check it out. The factors of 27 could be 1, 3, 9, or 27. The factors of 1 are just 1. But remember, these factors could be positive or negative 1, positive or negative 3. So you have to include all of those possibilities. So if we were to check each one of these over 1, plus or minus 1 over 1 would just be plus or minus 1. Plus or minus 3 over plus or minus 1 would be just plus or minus 3, right? Positive or negative 3. We'd have plus or minus 9 over plus or minus 1, which is just plus or minus 9, and same thing with the 27. So these 8 numbers, positive, negative 1, positive, negative 3, positive, negative 9, positive, negative 27, all 8 of those will be possible numbers that we will check to see if we can divide x to the third minus 9x squared plus 27x minus 27 and have 0 remainders. So let's try something like 3. So if we wrote this with synthetic division, we'd have 1x to the third, negative 9x squared, positive 27x, and negative 27. We're going to try to divide all these by 3. So remember, we always bring down that first number, that 1. Now we're going to check. 3 times 1 is 3. Negative 9 plus 3 is negative 6. 3 times negative 6 is negative 18. 27 minus 18 is 9. And then 3 times 9 gives us 27. Negative 27 plus 27 is 0. So we know that 3 is a factor. So the way we would write that would be x minus 3. 3 is going to be one of the zeros. Now look at what we have left here. It was 1x to the third power. So now after we divide by x minus 3, we have 1x squared minus 6x plus 9. That's going to be the other factor so far. Now you can do synthetic division again here if you'd like, but if you look at this set of parentheses, that's a perfect square trinomial. So you can square root 9 and it's 3. You can square root x squared and it's x. So this would factor to x minus 3 times x minus 3, right? Because negative 3 times x times 2 gives us that negative 6x in the middle. Now we bring down this x minus 3 right here. And here it is factored completely. X minus 3 times x minus 3 times x minus 3 equals 0. Or you can write that as x minus 3 cubed. Now, when you look at the exponent, the first one, the highest degree, that's how many zeros we're going to have. So we should be looking for 3 zeros. And we have 3 zeros. We have x equals 3. We have x equals 3. And x equals 3. So the way we're going to write this, identify the roots, really our only root is x equals 3. Now the multiplicity is how many times was that a root? So it's in there 3 times, so we would say x equals 3 with a multiplicity of 3. Now, that was pretty tough. But let's try another one, huh? Negative 2x to the third minus 12x squared plus 30x plus 200. What does Mr. Plan always say to look for first? Yes, a common factor. Well done. So 2 goes into all of these. And that first coefficient is negative, so I'm going to factor out a negative 2. So we'd be left with x to the third plus 6x squared minus 15x and minus 100. Now let's check if we can factor this by grouping. Hint, we can't. But you can always check. Common term on the left, 2 would be x squared, which would leave us x plus 6. Common term over here would be negative 5, which would leave us 3x plus 20. But remember, they would have to be the same thing in parentheses for us to use that method. So that one's out. So we are going to have to go with the rational root theorem, which again says that you take all your factors of the last term. So we're going to have the factors of 100, which could include 1, 2. I'm just going to put the plus or minus in the front. We'll put parentheses around it if that helps. 4 goes in there. 5 goes in there. 10, 20, 25, 50, and 100. Wow, that's a lot of possibilities. All of that, whoops, there should be a parentheses there too. Goes over the leading coefficient, which is 1 in this case, plus or minus 1. Now, we don't have to write those out now over 1 because we know that anything divided by 1 is just 1. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18 different roots that we can try out. That sounds like a pain in the butt, but I bet we can find them a little bit faster. So let's try it out. Synthetic division. Now, I personally probably wouldn't even try 1 initially because I gotta build up. I have to end up with positive 100 over here somehow. So I probably won't get there just by using 1. So let's try 4. Let's try that out. So 4 times 1 gives us 4. 6 plus 4 is 10. 4 times 10 gives you 40. Negative 15 plus 40 is 25. Ooh, that's a good sign. And 4 times 25 gives us 100. So it came out to 0. So that is a factor, positive 4. So the way that's written is x minus 4. That's part of the factoring. Don't forget, we also had that minus 2 out there. So we got to see what else is left here. So it was x to the third. Now this would be 1x squared plus 10x plus 25. So let's write that. 1x squared plus 10x plus 25. Now this isn't factored completely. We still got more work to do, baby birds. But if you look, factors of 25 that add up to 10 could be 5 and 5. So this would factor to x plus 5 times x plus 5, or x plus 5 squared. So if we bring down the other stuff, so here is this expression, the equation completely factored. So now looking for the zeros, we would say x minus 4, that x equals 4. X plus 5, that means x equals negative 5. And this x plus 5, x equals negative 5. So we would say x equals 4 has a multiplicity of 1. and x equals -5 has a multiplicity of 2